Good morning, good afternoon, everyone on the line. It's a pleasure to see all of you joining. So it's about 10 a.m. So we're about to start. We'll wait a couple of seconds so that everyone can connect quickly. Good morning, Carla. How are you?
I'm doing great. I hope you are too, Elizabeth.
Yes, I am. Thank you so much. We had more than 300 people that responded present for the session today. So we appreciate your great engagements as always towards robotic webinars and automation talks. We have a special invitee today, so I will present to you in a minute or so. I see a lot of people keep joining. I recognize a couple of partners here, a couple of customers. So thank you for joining us. Great. So 10:01 on our side here in the East Coast. So we'll start it right now. So welcome everyone to our next automation talks that is about ergonomics without palletizing. That is called Safety Pays. So making a case for a Cobot palletizer to reduce ergonomic injuries and provide an ROI. Today it's not a typical webinar where I go over a case study, a project from a customer. We really have a subject matter expert with us that I'll present to you, Carla, and she's the one doing the presentation. So Robotique didn't have any regard on everything that she will present to you. So a couple of words about Carla before she starts our session today. So Carla, she's a certified safety professional and a licensed machine safety specialist. She holds a master in engineering, and where she got it from University of Alabama, where she currently teaches machine safety management system in Birmingham, and she serves on the PMMI NC B155.1 committee. Carla, she has presented at major industry events, including the national and international robot safety conferences and ASSP conferences. So we're very happy to have her with us. She has more than 32 years of experience spanning pharma, manufacturing, and safety compliance. She's helped many organizations design safer workplace through prevention-focused strategies. So that's why we are very happy to have you with us, Carla, today. So the words are yours now. And I would just
Okay.
want to mention to everyone on the line that it's a live session, so feel free to reach out in the chat with any questions you might have, and there will be I can take some throughout the presentation or at the end for the Q&A session.
Okay. Thank you, Elizabeth, for that warm welcome. And good morning, good afternoon, good evening to everybody. I'm glad you're here. A lot of times people don't show up for safety types of presentations, but this is great that you're on board. One thing I do want to denote, because my people in safety compliance will understand this, especially in the robotic world, a lot of times we use the word Cobot palletizer. Is actually an industrial robot that is designed for collaborative applications. Okay, so I know that term's kind of changing in the safety standard world, so I just wanted to pull that out. So let's begin. So I like to start the scene today with a day in the life of manual palletizing. Every one of you probably is very familiar with this. This is where you pick up, lift, carry, twist, lower, place, position a component. Could be a box, could be a bag, could be pretty much anything that you're going to actually put onto a pallet. And sometimes I call palletizing packing off, where a worker does it. Well, it sounds so very simple. But is it? Is it a simple task? I thought it was a simple task too. I come out of the packaging industry originally. I actually supervised, managed production packaging lines, over 28 packaging lines at one time before I went into my safety career. And I really didn't think that much of this type of task until I did it. And when I said I did it, I didn't just lift up that box, and it was a box, and put it on a pallet one time. I put on a uniform. And I did this task for not a couple hours, but a couple of shifts. I wanted to see what it felt like, what it was like for the worker, and understand that one thing I found out about this task was it was very dull. When I say dull, it's not very motivating to the employee to actually do a pack off type operation. It was highly repetitive. Again, pick up, lift, carry, twist, lower, pick up, lift, carry, twist, lower, over and over and over again. The other thing that I found out, because again, we had over 28 packaging lines. So we had different pallet configurations, different weights of components, different sizes of the boxes or containers that we were actually palletizing. We're actually palletizing trays of vials, so a little bit of everything. But I found out that it could actually be dangerous. And when I say dangerous, that container might exceed my limits. The weight might be too heavy for me. The size of the container might be too wide, for me to get my arms, my wingspan, and grasp around it or be able to hold it properly. And when I say my limits, well, what are your limits? Everybody's limits are different. And the thing that I really noticed about this, with it being dangerous, was I'm only 5'2". I have some physical limitations. I am your older work employee. So with that said, the risk might be a little bit different for me than it is for you. But guess what? I'm your worker for today. I'm your worker that comes to work. I want a job. I've been hired. I'm going to do this pack off position. And do I really want to do this? No, I don't want to do this task, but I need a job. The other thing for you as the employer or the person, are you willing to take the risk of me having an injury? Are you willing to take the time to replace me? What are your options? What are some solutions? And when you find these options and solutions, how are you going to sell it to management? How are you going to tell them about the hazards, the risk, the solutions, their cost, and their benefits? So let's take a look today about what we're going to discuss when we look at this manual palletizing. So our learning objectives are, we're going to define what is ergonomics. We hear that word as a big buzzword a lot of times, but do we really understand what that is? We're going to learn about musculoskeletal disorders, and you're going to hear the term MSD or WMSD, and WMSD is worker-related musculoskeletal disorders. We're going to understand the types of injuries and the risk factors associated with manual palletizing. We're going to evaluate the direct and indirect costs of these WMSD injuries on the worker as well as the company. We're going to understand the pros and cons of 4 standard, very, very relative types of solutions I've seen across industries, and I've used every single one of these for preventing ergonomic injuries during the palletizing process. And we're going to utilize an ergonomic cost calculator to evaluate the solutions and access their impact on reducing these risks, as well as their return on your investment. We're going to understand how actually a Cobot palletizing solution can reduce and potentially eliminate all these ergonomic injuries. So, what is ergonomics? Well, Merriam-Webster defines it as an applied science concerned with designing and arranging things people use so that the people and the things interact most efficiently and safely. Whew, that's a big definition. But what it actually means is we're actually going to design the workplace to the human, okay, versus the human having to contort their bodies to the workplace. So let's think about it like this. Think about your car. What would it feel like if you could not adjust the seat? What would it feel like if you couldn't adjust the steering wheel? How would that be for a very tall person versus a very short person? So we've made adjustments to the workplace or to the car so people of different body dimensions can actually perform the task of driving the car efficiently and safely. And the key thing with ergonomics is we want to create a safe work environment. And with ergonomics, we try to design the workplace to fit the majority of the population, which generally is around the 95th percentile of the female workforce. So when we think about manual palletizing, this can actually create injuries. And the type of injuries that we see are 2 types. There are acute injuries. These happen immediately, such as strains and sprains. And you probably have all had them yourselves, maybe not doing manual palletizing, but doing overexertion tasks. But for manual palletizing, the quick lift, twist, turn, heavy exertion. All of a sudden, feel that burn in your back or your shoulder, or the burn in the lower back at the L4, L5 type disc location. These are acute injuries. On the other hand, chronic injuries, these are things that happen over time. They're not immediately. So what's happening over time, the lift, twist, turn, placing of the box, we're seeing fatigue. We're seeing a lot of cumulative stress on different parts of the body. So here you're going to see, like for the wrist, the elbow, the arm, carpal tunnel, tendonitis, epicondylitis. We can see it in the back, sciatica, herniated disc, and so forth like that. And what you're going to see is this is going to involve a lot of different types of muscles, bones, tendons, ligaments that you might have discomfort. You might actually have a strain or sprain, or you may actually have a tear, like a rotator cuff tear. But repeated or continual exposure to one or more of these factors initially may lead to fatigue and then also to discomfort. But over time, injury to the back, shoulders, hands, wrists, or other parts of the body may occur. So these injuries may include damage to your muscles, your tendons, your ligaments, nerves, cartilage, spinal disc, and also your blood vessels. So these types of injuries are called musculoskeletal disorders. And because they happen at work due to the exposure risks that we have provided in manual palletizing, these are considered work-related musculoskeletal disorders, or WMSD. So let's look at what are some of the risk factors while we manual palletize that can actually create these acute injuries and chronic injuries. Well, the first contributing risk factor are called physical risk factors. Here, as you see to the picture to the right or in the center, we have a person that's standing. It's called static posture. This is a position where they can't rest. In other words, they're standing, there's not a seat provided, they can't prop their leg up to provide relief to the back, the legs, the joints, the hip, the area. And as you can see, this guy is kind of leaning forward. So this is a static posture. The other is forceful exertions, picking up pretty much picking up, carrying, and lowering and positioning that box. Especially if the weight is extreme, you've got to take that physical feeling of picking up that box and actually placing and positioning onto the pallet. The other is pressure points. Here, as you can see, this box, I don't know if any of you've done it, if I've felt the sharp edge of a box or a container as you're trying to pick it up. In the picture, this person does have a protective glove, PPE, and that's to help him grasp the box as well as protect the edges of his hands as he's lifting that box. So these are pressure points. Another pressure point that is not displayed here is when you pull that box to your abdomen. You could put a pressure point to your soft tissues of the stomach. There are other physical risk factors, again, are the awkward postures, the bending and the twisting. If you look at the picture here, this person is bending forward to place a box in the center of the pallet configuration. Okay, so when we do this, we're actually feeling, where do you see, where are you hurting at right now? I'm hurting in my shoulders and in my lower back. And look at his knees, how he's having to bend over to get to that. So there's a lot of pressure put it on in that area, these awkward postures of extending the arms. So what I normally see, and I've seen this in a lot of different companies I work for, is they'll say, you're not supposed to lift anything heavier than 20 pounds. Well, that actually came from a lift analysis, but that lift analysis was it from a simple lift of straight from the floor, straight up, or straight from a higher level to straight down. A simple lift up, down. This is not a simple lift. This is actually extending my arms. And by the way, when I extend my arms, that weight just increased about 3 times. So that's approximately 60 pounds of torque and pressure I'm putting on the lower back. The other physical risk factor, again, is the repetitive motion of the bend, lift, twist, and positioning of the box. All these can contribute to that injury, whether it's acute, quick, exertion, or repetitive over time where we feel discomfort and fatigue, which lead to a higher level of injury. So the other contributing risk factors are personal risk factors. So these come from what people bring to the industry. These are factors that we have no control over. And guess what? I probably can't see these risk factors. A person may be more prone to have an MSD if they have pre existing factors, like maybe they had a previous injury, maybe they have already had issues with torn ligaments or muscle strains in specific areas, which has caused weakening. The other is genetics. Those people that may have arthritis or joint instability may cause them to actually have an injury. Also, a person's physical capacity to do the work. In other words, do they have the strength, endurance, the flexibility to actually do the job? Also, a person's lifestyle habits. Do they smoke? When you smoke, that can cause actually restriction in the blood flow to the muscles, which can actually create an opportunity for an injury. Also, different types of habits. For instance, what if you're highly obese? You've got a heavier weight on your hips, your back, your knees, your feet. And now I'm trying to lift, flex, bend, twist, all that repetitive motion. I might be more prone to have an injury. Doesn't mean all these will cause an injury, but I'm more prone to have an injury. And then again, lack of physical exercise. The person may not have the endurance to do that or the flexibility to actually palletize. Now, what I'd like you to do is look at this picture. I know you've been looking at of all these people, right? Well, guess what? These are your workers. Can you tell me which one of these has personal risk factors? So honestly, looks can be deceiving and countries have their own laws and regulations to protect health data and patient privacy. So you may not even know if any of your employees have any of these personal risk factors unless they tell you so. So these are things that they bring into the workforce. Another risk factor that we see, and this is not one that we normally hear about, are the psychosocial and organizational risk factors. So here what happens is when we provide manual palletizing as a task that we provided to our employee, it creates a high work demand. They're having to keep up with the production line. And it actually creates low autonomy. When I say low autonomy, they don't have a choice of can I change a position or can I do this a little bit differently? Or, so everything is pretty much run by this is how you do the task. You pick up, you lift, you twist, you turn, you place. Okay? There's not an option of any types of change there. There's no lacks or breaks of opportunities to change work positions. So as you can see to the picture to the right, these people are working off of a conveyor system. You see people with different body sizes, shapes, heights, and whatever. So there's for one person, it might be too high or it might be too low. So I can't change my posture because I'm working around the type of work environment. I also may have to work at high speeds depending on the rate or the speed of the production packaging line. I may have to work long hours or on long shifts. And especially if you're manual palletizing and you're doing this for hours and days, again, you're creating cumulative trauma to different parts of your body. The other one that we don't hear much about, and this is a psychosocial and organizational risk factor that can occur, is bullying, harassment, and discrimination. And you're going, I don't understand that. Well, I personally have seen this happen in production packaging. What happens is if I'm assigned to do a pack off position, and maybe I have one of these personal risk factors, or I don't actually want to do the task, I may actually bully somebody on my team to actually do this task. And therefore, they'll have to do the task maybe more than one rotation or for out my shift because I don't want to do that task. That's bullying. Discrimination. Well, how does that occur? Well, it occurs when, guess what? Let's say I've got 7 people on my work team, and I've decided 3 of my work team, they need to pack off because I know they're stronger, they're more fit. I feel like they can do the task better. Or maybe, they don't have the knowledge and the training to do some of the other tasks on the line. Well, because I've only picked those 2 or 3, and the other 4 or so get to do more enlightening, more motivating types of tasks, I'm kind of discriminating against the work team. And also, above all, this is low job satisfaction. Nobody wants to come to work and do that repetitive, over and over, mundane type of task. We want to be fulfilled as workers, to know that the types of jobs we do provide us joy, that we can do it safely, and that we feel stimulated by the type of work that we do, that we add and we create benefit to the company as well as to ourselves. So let's take a quick poll. And I'm going to need my assistant Elizabeth's help, and we hope this goes well. How much of a priority or safety risk for your company's leadership? Is it a top high priority, center, front and center, moderate? Comes up sometimes. Low priority, rarely discussed. Not a priority, almost never talked about, or maybe this is just not applicable and you just want to learn a little bit more about ergonomics. Can we run the poll?
Let's go for the poll. So we're launching the poll. So everyone, it's your turn to take action, to give your experience, your feedback on that question. Thanks, Carla, so far. So we're already half of the people on the line have voted. So go back to your screen and share with us your thoughts so we can have a good representation of everyone on the lines. Let's reach the 70% of the people on the line voting. Great. So I think you'll like the result, Carla. So I'm
Yeah,
gonna.
top high priority. It looks like we have people that are very, that's great. When you've got a culture where management is concerned and they want to make sure that we put this front and center, then you've got a great workforce, a great management that wants to actually do something. Okay. So can you see my screen or do I need to share?
We are back.
Okay, perfect. So when a person gets injured, it has a lot of impact. It impacts the worker. After an injury, they feel stress, they have low morale, they have anxiety, and somewhat fatigue. These are called physiosocial factors where they feel isolated. They feel like they're not part of the team because they've had an injury, kind of feeling fearful of going back to that type of job. It also impacts the company because what we can see here is we may have now a start of increased absenteeism, high turnover, increased insurance premiums, and also, poor public image. And I've seen this happen in other companies where if you have a lot of incidents and accidents and it gets out to the public, nobody wants to apply for a job there. They hear the work's too tough, it's not stimulating. So, this is not what we want to do. We want to create a safe work environment that everybody wants to come to work to be part of, as well as we want in our public viewpoint that this is a great place to work. Well, statistics, and we all love statistics, but we need to talk about these. Most of you say, well, I've never had an ergonomic injury. I want you to change that mindset around and go, it's just a matter of time before I have an ergonomic injury if I'm manual palletizing. In 2020, in the U.S. manufacturing sector, strains, sprains, and tears contribute to 11% of all non fatal occupational injuries and illnesses involving days away from work. If we further look, the National Safety Council looked at dark cases, and this is days away from work and restricted or transferred duty in 2021 and 2022, and this is just for MSDs. 72% was to strains, sprains, and tears. The part of the body, as you can see again, is going to be the upper types parts of the body. And the event is overexertion, 33% to lifting or lowering that box. So again, injuries are going to occur. It's not that you haven't had one. It's just a matter of time before you do have one. And we want to create that safe work environment, again, where we don't have people get hurt. We look at these statistics, these are all just numbers. But guess what? There's a person behind each one of these numbers that have actually had an injury to a type of MSD due to, the sprains, strains to manual palletizing or overexertion type things. So we always need to keep that in mind that there is a person behind the number. So a quick another poll. Do you feel your current manual palletizing process could cause an injury? Yes, no, maybe. I'm not really sure.
Let's go for the second poll. So thank you for your great participation on the previous poll. So now it's your turn again. Ask her the question after what Carla
Wow.
shared. Do you recognize yourself in these situation. So almost half of the
Maybe
people on the line
and
voted.
yes. Wow. Ah, that's scary. Well, I'm going to give you tidbits that's going to help you move forward. Okay, let's go back.
So again, more than half of the people said yes to the question. So, but you're not
Yes.
alone. Don't feel as different. You're not alone. We totally understand, and that's where we know ergonomics must remain an important topic for a lot of manufacturers.
Okay.
I'm closing there. Back to you, Carla.
Okay, perfect. So if you're not sure, we actually, which I wrote an ebook, it's Manual Palletizing Ergonomic Risk and the Need to Incorporate an Inherent Safe Design. That means designing out the hazard. So if you're not really sure, maybe, or yes, I think for sure we're going to have an ergonomic injury, there are tools available that you can actually do a risk assessment to actually look at, is my lifting process within a safe lift limit, or is the physical demands, the cumulative physical demands, because palletizing is not just one straight up and down lift. It's cumulative because you're actually lifting and lowering to different heights continuously on different levels of the pallet, and therefore you get a lot of cumulative trauma to the body. So I've provided some tools here, and I would highly recommend that you get with your safety person at your site to actually help you perform what's called a NIOSH multitask lift analysis, which will create a composite lifting index. And if you need to actually look at the multi-lift analysis and the composite lift index. I know that's a lot of terminology, but this will give you an opportunity to kind of look at it and understand that it's not just a simple process. Anything manual palletizing is a very complex process. So, with that, there's always cost involved. We have direct and indirect costs of recordable injuries. Well, what's a recordable injury? Well, a recordable injury is anything that requires medical treatment or days away from work from an OSHA, and that's in the United States. So, and with that, we have what's called direct and indirect costs. Direct costs, and as you can see, I've got a picture of a beautiful iceberg. The direct costs above the iceberg, or these are the costs that we all see. The medical costs, the wages of the injured employee, rehab for the employee, increased insurance premiums. But as you notice with this iceberg, the indirect costs below this iceberg are actually even bigger. These are increased paperwork, investigation costs, loss of production, overtime. Oh my gosh, the training, retraining, rehiring, back and forth, that type of thing that we just assume these costs. But over time, these cost a lot of time and money. The last category, which a lot of times people don't think about, is our reputation damage. The legal fees. If an employee reports this injury, or if OSHA or one of the regulatory bases have to come into your site to do an inspection, there's going to be legal fees and fines, which therefore is going to decrease your opportunity for future bids. So again, injuries and ergonomic injuries cost a lot of money. So, what are we going to do about it? Okay, we understand there's risk factors that we need to be aware of. There are statistics that show me that I'm going to have an ergonomic injury, and a lot of you say I think we're going to have one. So we're going to look at 4 palletizing type solutions, and a lot of these are already used in industry, and I've used all 4 of these. The first is proper lifting technique. The second is job task rotation. We're going to look at lift tables, and we're going to look at a robot, an industrial robot that has a collaborative application for palletizing. And over to the right, I want to bring this to your attention. This is the hierarchy of hazard control. Well, safety professionals, industrial hygienists, and ergonomists, and all of us in that type of field, we look at when we identify a risk, we decide how are we going to reduce that risk based off of the severity and the probability of having that risk. As you can see, the most preferred method is providing an inherently safe design. In other words, if I design out the hazard through elimination or substitution, I don't have any issues, right? There's not going to be an injury. The next is providing an engineering control. This could be guards, control functions, or different devices to minimize that exposure. And the least preferred are going to be your administrative controls. Awareness means training, supervision, and of course, always the last is going to be PPE. So let's look at each one of these controls, what they are, and actually how they work, the pros and cons of them, and how they rate against the hierarchy of hazard control. So the first, as you can see, is going to be the pro of, I'm sorry, the first is proper lifting and lowering technique training. Look at the picture. Most of us have been through this training or know what it is. Here's what you're supposed to do. The correct way is I want to position the box or the container close to my body. I use my knees to lift up, and then I place the container. It's dependent on that container being close. The incorrect way of doing this is to bend over. And again, you can see the back, the legs, the shoulders, and therefore more susceptible to an injury. So we want to train people to actually use their knees and do a proper lift. Well, the pros is it's easy to implement and it's minimal cost. We're just looking at training employees. Here's the cons. It's dependent on your employee's behavior. I don't know about you, but the speed of the line, the production, everything that's going to happen, I can't say my employee 100% of the time is going to do that. The other thing is, are they actually capable of doing it? Remember, we saw the picture of the man extending his arms to place the box into the center of the pallet. So also when that occurs, I'm extending. I'm not in the center portion of my body. Again, not all lifts are the same. When I say that, the size of the container, the weight of the container, the placement of the container, the lift, to the height, the extension, so all the lifts are going to be different. They're not straight up and down where I can position that container properly. Again, this does not eliminate any of those personal risk factors that the employee brings. And there's no productivity gain. And when I say productivity gain, this means that it's not speeding up production, as well as there's no reduction of exposure to the employee enough to create a positive outcome. So if we look at the hierarchy of control, you can see it's training. And this is probably one of the least effective other than PPE, because again, it's dependent on the employee's behavior to do the task right every single time, as well as they're not going to be able to put the load in front of them every single time if the container is of a different height and they're having to place into a center of a pallet. The next is job task rotation. And I've done this as an industrial
Mhm.
hygienist.
We
Here, what
have,
we
excuse me, Carla, we have a good question on the chat, and I think that it goes back to one of the slides that you've shared. So would you like to take a question?
No, I would actually like to move forward, and can we save that question to
Okay,
the very end so that we can get through our slides? Thank you very much for asking that question. But if we can keep our questions to the end so we can finish the presentation on time
perfect,
and then have that 15 minutes, that will be perfect. Okay? But keep those
perfect.
questions coming. I really want to hear them. So, job task rotation. What is job task rotation? Well, this is where we actually have an person that rotates out. So, sometimes palletizing is the employee does that task for the whole shift, or I rotate in every 2 hours. So I have one person do it 2 hours and then the next person do it 2 hours. As you can see, I've got people double palletizing. Okay. So if I do job rotation, what actually occurs here is that person does it for a minimal amount of time, say an hour, 2 hours. They rotate out to another task or job that doesn't put the same type of stress on the areas of the body. So it might be a sitting position or something that's not having as much endurance that this has. Again, easy to implement, minimal cost. It reduces the time of exposure to the hazard. It improves comfort. It's going to reduce your fatigue. And it may be more production efficient. The people might be able to keep up closer with production if I'm using two people. If I'm using one, they may be able to keep up with production depending on the speed of the line. The cons is, do you have enough employees to rotate in? You may or may not. Okay. What if you did decide to do this and an employee is out that day? Now it double loads on another employee. Also, and this was brought up by a colleague of mine, it exposes more people to the hazard. So even though I've reduced the exposure time, I now have more people doing the task. And again, not all lifts are the same, and it does not eliminate the personal risk factors. If we look over at a hierarchy of hazard control, This is an administrating safeguarding method. We're actually providing a safeguard because we're minimizing the exposure time, but again, it's an administrative control. The next are pallet lifts. There are two types I'm going to talk, and there's several types of pallet lifts, but I'm just going to bring these up. And I do want to say I've got pictures and I have the names of the providers. I'm not endorsing any of these. I just need to provide citations for the pictures. So these are pallet lifts and they're stationary and rotating. If you look at the blue lift, this is a stationary lift. It's generally electric or it could be hydraulic. I can raise and lower that lift up and down. Okay, so I can adjust, the person can adjust the height to where they need to place it. The bottom are rotating lifts. The red one you see, that's actually a spring-loaded lift. How that actually works is a maintenance mechanic actually sets that spring so that he puts a pallet on top, and what happens is he then places a box or the component on top of the pallet, and he looks at the height and goes, that's the height I want to work off of continuously. So as people put another layer of boxes on, the lift actually goes down, but the height remains the same. Okay. This has actually a rotating turntable on top, which is good because now instead of me having to walk around the lift, I can actually pull that pallet around. Now, notice I said pull, okay? So I might have to pull and push, so that's another type of force. The green one, as you can see, it's got the nice little yellow rotating table. This is a scissor lift. It is electric, I can tell that. And with this lift, what I can do is, again, I can lift it, I can raise it, lower it. I can actually use a control to turn the table, or I might have to pull that around, okay? And as you see, I also have a ramp because that pallet lift is not at zero. In other words, because it's up at it's got like 3 or 4 inches, I can't get my pallet jack up to that height. So I might need a ramp to roll up, insert my forks, lift it up, and then roll it back down. So the pros of this, it adjusts the heights of the pallets to reduce the amount of lift or lower. It may reduce the amount of holding a box and walking around the pallet. The minimal cost of these can run anywhere from 5 to 7,000. And what it does is it reduces the level of exposure or lift lower, and it actually creates a minimum impact on production efficiency. In other words, I'm actually able to keep up a little bit more with production, and I'm reducing some of the fatigue to my body because I'm not having to raise, lift, and lower because I've adjusted this to my height. Although I will say this, the scissor lift or the spring-loaded lift at the bottom is set. So if I'm a very tall person or a very short person, whomever set that up for the right height might have set it up for themselves. So the cons, pallets lifts need floor space. They might need that on-off ramp, so they're going to take up some space. They're usually dedicated to an area, and they also provide other hazards. They have cables now, which can cause trip hazards. The rotating pallet, the edge of the pallet can actually strike a person. There are also potential pinch and shear hazards. A lot of times what I've seen is the manufacturer might put labeling to identify where these hazards are, didn't eliminate them. Others have done more high tech and put sensors in so that when you lower the lift, it can actually stop so you don't crush your foot. But again, you need to look at these because you have to identify the hazards and risk and provide the controls as the employer. And again, these take maintenance, and maintenance has to set these up, and training of, the operators that actually do these. And again, these do not eliminate personal risk factors. And again, there's some reach, lift, twist, push hazards that we have because these do not eliminate the opportunity of maybe having to walk around, or even it doesn't decrease the distance of having to place the box in the center of the pallet. If we look at our hierarchy controls, this is an engineering control. It is better than the behavioral base that we're looking at people doing the proper lifting technique. The last is a palletizer, a Cobot palletizer. The pros of this is it completely eliminates the exposure to the hazard. We've increased efficiency, consistency, and production throughput because we're not looking at manual labor. This is set up for the production line. is speaking to the production line. It's set up so that it knows the production, the rate it's got to run, so it's going to be consistent. It can handle up to heavy loads from 20 to 35 kgs, which I know a single person cannot do, not unless, they're very buff, and then we have other risk factors. The adaptability to different pallet configurations and different product types. So we're not just looking at boxes, it could be bags, it could be, trays or anything like that. It takes up minimal floor spaces and it can be easily moved to other locations. The cons are that it costs approximately around $140,000. It runs at a slower speed than an industrial robot. And when I say an industrial robot, remember I told you a cobot is an industrial robot that is designed for a collaborative application. In the picture, this type of robot has sensors that has been set so that if it actually strikes a worker that is below the pain and the injury threshold for the body area that it could potentially strike. And all that has already been set up and put into a collaborative type robot, a robot designed for collaborative. An industrial robot, on the other hand, is in a cage. Okay, we've caged that robot and it can run at very high speeds and do a lot of more heavy weights. So again, this one's going to run a little bit slower, but is highly effective for those heavy weights and good production speeds. Again, it takes maintenance. Maintenance has got to set this up, and we all have to be trained on how to actually set up the pallet pattern and actually get the machine up and running. Again, another con is worker perception. Workers might go, "Oh my gosh, I'm scared. This is one of those robots, that's going to kill me." Or it could be the worker might think, "Oh, that's a robot and it's going to take over my job. I'm going to be eliminated," because everybody wants their job, right? We all want our jobs. But the difference is we're now going to remove that worker from a dull, remember, dull, mundane, repetitive, and potentially dangerous job and put them into a job that is safe, that's more motivating, something that they can feel better fulfilled. And we've created a safe work environment for that employee. So if we look at our hierarchy of hazard control, this is exactly where I want to be. I'm using an inherently safe design. I've actually eliminated the exposure risk to the hazard by removing the worker from doing this specific task. So everybody wants to know cost. That's a big thing. So if you do have an ergonomic injury, they're going to cost a lot. And so what we found out is that organizations frequently cite the perceived cost of ergonomics and their programs and the solutions as a barrier to actually implementing them. So while the benefits of ergonomics are fairly easy to quantify following implementation, they actually can be difficult to estimate when attempting to justify an investment or an ergonomic intervention. So, this is the one reason that a lot of times when you go to management, the first thing they say is, "How much is it going to cost? What am I going to get out of that?" And it kind of dominates the discussion for ergonomics. So, today we're going to look at some calculators that are going to help you present this to management. Now, if you've already had an ergonomic injury, what better yet than to use a couple of these calculators to actually show what could occur if that injury continues to happen. Physical evidence is better than anything, but a lot of times that injury may not have happened yet, and I need to provide a case on my return on investment. So the United States Department of Labor, OSHA, has a calculator called Safety Pays Program Calculator. It actually works off the National Council of Compensation Insurance. So they take all this insurance data and they look at the type of injury that you have had, and they'll say this was the direct cost, and then they formulate what the indirect cost is. And generally, small claims cases actually are going to be at a higher rate of indirect cost than large claim cases. Okay, so we have that. This calculator also allows management to actually see how much I have to actually provide in production to offset the loss of an injury. So we also have another calculator, which I highly recommend, and that's the Washington State Ergonomics Cost Benefit Calculator. This was actually developed by Rick Goggins of the Puget Sound chapter of the Human Factors in Ergonomic Society in the Washington State Department of Labor. And this one was based on 250 ergonomic cases directly, and it pulled in that OSHA calculator for your direct cost, and it pulled in the Washington State, the SHARP data, and the SHARP data primarily is the safety, health, and looking at risk prevention data. They actually looked at nothing but MSD type of ergonomic things, and they pulled in the indirect cost for these. So that pulled that all into the calculator. If you're from Canada, just a heads up, there is an Ontario Ergonomics Intervention Cost Benefit Calculator. This actually uses the Washington State Ergonomics calculator, but then it pulls in the Worker Safety IB Insurance Board injury cost data. So either of these are fine to use. Again, this is to help you prepare to provide that conversation with management of the cost of a potential ergonomic injury. And by the way, all this will be provided to you in resources after the presentation. So when I provide you the links and stuff, you're not having to copy it. We're going to provide all this to you, as well as other resources to help you understand the data behind these calculators. So let's take a look. The first page of this calculator, as you can see at the bottom, there's a tab. It says Workers' Comp, Input Solutions, Benefits, and Payback. I just, for this scenario, I said I've got 8 workers, and these are the workers that are actually doing the manual palletizing task. I might have 20 people on that packaging line, but only 8 do the manual palletizing task. I guesstimated $20 an hour for them to do that. I then have drop down boxes as I need 3 years of data to actually do this calculator. So for a scenario, and as you can see, the types of injuries in the as I show the drop down box to your right, I can select these. So I've selected for my first year, I've got a back strain and a rotator cuff. It automatically populates the typical cost, and you can see that. The next year, I pick a shoulder strain. You see the cost for that. The second year, I have sciatica. Wow, 63 over 63,000. That gives a total cost for each of those years, and then it provides an average annual WMSD claim cost. So that annual cost was $50,425. Then it's going to give an estimate of the annual indirect cost. Again, as you see, that's higher than the direct. So we have, as you can see now, a total of $105,893. Whew, that's a lot of money. So let's look at the second tab. We're going to put in just 3 of the options, and this calculator only allows for 3. We have 4 solutions, but we are going to look at the 4th solution last. We have employee training, job rotation, and pallet lift. As you can see, I have a training cost. That's 8 operators. I paid them $20 an hour. So you see the 160 is a reoccurring cost, and so it gives me a total intervention cost. The effectiveness of the solution, it relies on employee behavior to do it right every time. The productivity improvement is there's no really productivity gain. Same thing with job rotation. You can see primarily the same. The only thing here is it does reduce the time of exposure, and it's low. The productivity gain is low, improves comfort, reduces fatigue. The pallet lift, on the other hand, costs around that 5,500. Engineering costs to actually install, training costs, recurring costs, total cost of invention. Here, I've actually reduced the level of exposure, and I've reduced waste motion. So there is some productivity improvement. So now the next tab, what are the benefits? If you look at the lower before you look at the options, I have reduction in claims, solution effectiveness estimates, and as you can see, there's reduction in claims. Here, if I eliminate the exposure, I can get 70%. Okay, and eliminated exposure here is if I have to come back and utilize it, not 100% of the time. And you can see the bottom is relies on behavior. It's only going to give us 10% solution effectiveness. If I look at productivity improvement estimates, again, we're actually showing how we can actually, the worker is actually providing some productivity improvements by actually doing this task. So here, what we're actually seeing from a productivity improvement is that workers, again, are not going to be 100% productive, and they may only be 85% productive in optimal conditions. So I am seeing some additional improvement in them being more productive if I provide certain types of things. Okay. So, and as you can see at the bottom, I provided the initial cost that we showed. So employee training is a reduction in claims by 10%. So if you said 50,425, 10% of that is 5,043 and so forth. And as you can see, the total estimated annual saving is going to be 10,589. And we see cumulative, again, for the 3 and the 5 years. Job rotation. Here what we have is a reduction of 15%. We do see increase in productivity. That provides us a value back to the cost of the worker, feeding into that production line. You can now see the total estimated annual savings and 3 and 5 year estimates. The pallet lift, again, that's 40%. We've reduced the level of exposure. That's 40% payback of that annual cost and indirect cost. Okay, so as you see, we're doing better at reducing our claims because we're reducing the exposure risk of an injury. Increased productivity adds some additional money. So then we have a total estimated annual savings of 55,957. Estimated savings over 3 years and 5 years. And again, when we do this, we're going to look at next. There we go. Our payback period. So our payback period for these three things, as for employee training, I'm going to get immediate payback, okay? I mean, I've just trained the workers. I do recurring costs, and you can see that we've added those benefits. Job rotation, where I'm looking at here is going to be almost an immediate payback again for this type of task. Pallet lift, on the other hand, is going to take a little bit over a month to actually pay off the cost of that pallet lift. So these are quickly ready, to actually implement this type of control. It's going to pretty much pay back itself immediately. But the key thing for these is you still have a probability of an exposure to the hazard that you could have an ergonomic injury. So even though we had a reduction in the probability or the potential in reduction of those claims, you could still have an injury. So let's look at the Cobot Palletizer. Here, if I use this 100% of the time, I totally eliminated the injuries. It's going to be consistent with production. If you look at option 4, which I've added the little chart to the top, that Cobot, the purchase price of the robotic arm in defectors, generally around 110,000. The engineering cost, and this is a cost to install, to program, to reconfigure some areas in the production area, is around 30,000. Training cost is going to run, all day training for your people is about $1,500, and the recurring cost, this is for PMs. Okay, you don't have to retrain your operators on this. This is going to be about 500. So the total intervention is 142,000. Again, if we looked at our average injury cost, that was 105,893, right? So our first year annual benefit, we're at a deficit, $36,000. The payback period is 1.3 years. But I want you to look at the estimated payback, and this is subtracting out the initial cost, for the 3 year and 5 year. We're looking at a high return not to have an ergonomic injury. It literally pays for itself because I don't have the personal risk factors. This doesn't have personal risk factors. I don't have the probability of having an injury because guess what? A person can have an injury, immediately. They could have an acute injury or they could have the chronic. I've not even set myself up for that failure. So it literally pays for itself. And I have installed this on so many production packaging lines because I realized, similar to what you guys did, that we're setting ourselves and our people up for an injury. And again, these are people. These are just not numbers. These are people that I want to come to work and be healthy, happy, fulfilled, and want to return. I want to create that safe work environment. So again, we're not eliminating the worker. We're actually placing them in more fulfilling jobs. So, what are we going to do? How do we get started? Well, we need to perform a strategy. And most of you are thinking, like, gosh, we're going to have an ergonomic, issue. Well, are you? Well, first thing you got to do is you've got to perform a risk assessment of your current manual palletizing process. You can't say I think it's going to be a major injury without doing the math behind it to actually look at. You then need to look and evaluate the solutions to reduce your risk of an injury and provide that return. Decide what is the better solution. You might say, well, we're lifting itty bitty boxes and we only do it, for 30 minutes. Well, then maybe behavior, safety training is the way to go. But more than likely, you're running production lines. And like I was, this wasn't what I needed to do. I needed to put an engineering control. I need to design out that risk. I then need to implement that ergonomic solution. And here's a big thing: do not walk away. You need to monitor that ergonomic solution. Your people are your greatest assets, they're the sharpest end of the sword. Go back, talk to them, see how it's working, see what the benefits are, see do they like the solution that you put in place? And if not, then go back, see what we need to do to put in what is actually needed for that type of operation. And again, it all begins with a risk assessment. And that risk assessment may be going back to that NEOSH lift limit and lift analysis types of tools to actually provide you that data to say this is an unsafe lift or process. Okay. So, again, our goal is to create a safe work environment. So again, here's the resources that are going to be provided to you. Everything from the ebook to the calculators that are going to be provided to you, and also we've got a lean cost calculator that Robotique has that you can actually look at the payback from a production standpoint, and versus like more the employee injury standpoint. Okay. And here's my contact information. So we've got a few minutes. I'd like to open it up for some questions. I know that was a lot of information. And as you see, you've got my contact information. I am available if you'd like to shoot me an email if there's anything that I can help you with, because I have a passion for inherent safe designs and robotic palletizers. Any
Cool.
questions?
Great. Thank you so much, Carla. We've seen the attentiveness of the people throughout the entire presentation, so deeply appreciate and thank you for also to all of you for your participation throughout the polls. So I'll dive right in through the questions. So feel free to share the ones. We still have a couple of minutes, but other than that, we can follow up after
Sure.
one by one. So we have a great first question from Marana. Thanks, Marana, for your question. So, do you have any feedback or suggestions when it comes to destacking pallet that is not a forklift? Our people detach and load pallets into our robot, and we haven't found anything to help so far.
Can you
So,
repeat that question again? So you're talking about pulling the pallet out?
So me too. I had to. I wasn't sure about understanding, but here, having had the time to analyze it a little bit. So, any feedback or suggestions to when it comes to this stacking pallet that is not a forklift? So it's a customer that has the robotic palletizing solution, if I can say without mentioning, and I guess that's a problem that other manufacturer also face is that even if the boxes are palletized by the Cobot, how do you bring the pallet maybe to so that
Out? How you pull the pallet out?
exactly.
Generally you use a pallet jack. Any type of material handling lift can do that to pull that pallet out. Pallets are configured a certain way to actually put forks in. So fork trucks, and if you do fork trucks, we do have automation so that you can actually use AMR type of autonomous mobile robot type palletizing pallet. They can actually pick up that lift and move it. It doesn't take the whole space of a fork truck if you use that. So those there are designed to do that. And maybe that provided you the question. The other issue that you have from an ergonomic standpoint is if it's a heavy load with a fork lift, you will have to, and you may want to get your industrial hygienist or safety professional to actually do what's called a push pull force limit to see if the initial push and pull actually affects can cause a strain or sprain, and that is an ergonomic issue as well. So
Exactly.
what we try to do is if it's very heavy load, I use a fork truck, or I can use like an AMR type device. Therefore, I'm removing the person from actually pulling or pushing.
Yeah.
Okay.
Exactly. And another great asset. So I think Marana we understood well. So she added or he the stacking a pallet uh, other pallets. So I shared to all of you in the chat a link. It's a video that Robotique and UR just posted this morning. It's an example of a bakery manufacturer who integrated the solution with a pallet dispenser. So that might be also one of the solutions, so that the pallets are automatically dispensed to the robots so that we
Yeah.
can
And
palletize them.
I've used the automatic pallet dispensers. They're really good at you have a fork truck that puts it into the dispenser, a stack of pallets, and then the pallets are actually automatically dispensed over, okay? But then again, as you remove that filled pallet, you're going to need some type of tool, whether it's a pallet jack, fork truck, or an AMR type thing.
Perfect. Thank you so much, and thank you so much, Carla. So Paul says from DHL says, "Nice job, Carla." Here we have another question from Kunjan. I appreciate Kunjan the question. So, is there a case study on the adding the rail underneath the conveyor to have support for leg that helps in reducing the strain on the person, and how is standing for 8 hours?
Okay, are you talking about the conveyor? So that when that box or a component comes down, you've got a conveyor, or you're talking about the support of that? Just want to make sure I understand what you're talking about. And
So,
can it be moved up or down, is what you're saying? So I can so as it comes down, I've adjusted the lift and the lower before I move it to the pallet?
maybe we can follow up also one by
Yeah.
one. And Jonathan is asking a good question so about safety of the cobot. So we can continue that offline. So he says how the robot can be safe, especially being able to move boxes at 35 kilogram. If it drops at a box at that weight from 8 feet high, to me, it's a physical threat for a human. So definitely, Jonathan, this is an important safety analysis, and we can share with you the example of all the possibilities. So we use scanner so that every time a person enters an area close to the robot, that the robot stops. And if the robot stops, it doesn't drop the box. It keeps the hair flow, so that it keeps the box high. And we can also have reduced speed of the robot depending on the areas. We can have also gating, fencing. It really depends of the risk
Application.
assessment. Yeah, and
Yeah.
the
Can
application.
I speak toward this, Elizabeth? Because I do this for robotic risk assessments for a living too. So when you're doing this, you've actually got a robot here that is designed for collaborative application. The manufacturer of that robot, if it's designed for a collaborative application, has met safety compliance standards. It has actually built-in sensors, so it based off of torque and force reduces the speed. So if it actually comes in contact with a person, it's not going to cause pain or injury. Those are the two requirements going back to a safety compliance standard. Now, if we know that we need to operate the robot at a higher speed that's going to be above those safety standard limits, then what I need to do is I need to put in additional controls. The additional controls can be everything from a safety scanner, so that therefore if the person, as they approach that area of control, the sensor actually detects it, slows that robot down until now they come into another zone and the robot has completely stopped before they come in contact with the robot. Then, as that person moves away, the robot can slowly start back up. And when they're out of that danger zone, it then runs back at a higher speed. Or you can completely fence it. So now I've got an interlock door and I go in. Now, to holding that weight of that load, and you're scared that it's going to drop it, again, the risk assessment is going to determine that you may need to have a safety scanner. But generally, for those types of force and load requirements, there's a valves that are created so that they're going to fail safe. So if I actually, what if I lose electricity? What if I lose pressure from that vacuum system? So the valves are created to fail safe so that you're not going to actually drop that load. And again, that goes back to that risk assessment, determine what could potentially fail, how is it going to fail, and what are the controls that we've actually put in. Okay. And
Mhm.
that's part of the risk assessment that is required, a collaborative risk assessment that's required by the end user and the integrator when they install that robot.
Exactly. And so, Jonathan, I appreciate your question, and I think we can discuss this aside because he says so is it getting similar to an industrial robot? So definitely the perks of working with collaborative robots is mainly the ease of use, also the fact that it's so easy to program, that it's very flexible. But in terms of the security, it really depends on the application.
Mhm.
Usually working on collaborative speed also is a first start, but definitely it's worth exploring your application and comparing the solutions.
And let me just say something real quick, and I'll put my production hat on because I've worked years in production. Floor space is gold. You know, that's your commodity. You want to reduce the amount of floor space because you got other things, process flow for that production line, whatever. So putting in a robot designed for collaborative application reduces that floor space. If it's running after you do the risk assessment, if it's running at the speeds and the quantities that you can, so that you don't have to put in that safety scanner, and you still can. And the distance of that safety scanner has to be determined by that risk assessment. Um, but you know, if you do that, that actually opens up that floor space. If I have to cage a robot, now I've got a fixed cage around that robot. I've actually increased the amount of, or decreased the amount of additional floor space that I could have. It's not saying it's a bad thing. It's just when I design and I lay out a production line, I need to be aware that I'm going to need that amount of floor space for an industrial robot that is caged, and I've got to ensure that I have complete process flow, input, output of that production line that's going to work for the employees, the traffic control, and the in and out of the materials I need to put on that production line.
Definitely. So we have a couple more questions, but we're already 5 minutes past 11 here on the Eastern time zone. So first of all, I want to take the time to thank Carla. So thank you for sharing all that information with us. Rick says good job on the
Thank you,
chat. So
Rick Goggins. By the way, the guy that actually developed the ergonomic calculator is online. And it is a phenomenal calculator. A lot of work. People don't understand the amount of work that went into that calculator. So I'm very impressed with it. Thank you, Rick.
thank you for joining. Thank you to everyone on the chat. Thank you for Kunjan, from John here. So appreciate everyone on the line, and so everyone will get the recording and the credit hour and a half that is related to the hour of. With the webinar, and so you'll find also all the links that Carla shared within by email with the recording of this webinar. So again, thank you so much, Carla. Thanks to everyone on the line, and see you on the next edition of another Automation Talks.
Yeah. And if you need help, email me.
Have a great day, everyone. Goodbye, Carla.
Bye bye.